So you get my email? Quiz today during lunch. Okay, and
What do you mean?
Jeanette's here.
Yes.
Excellent. It was nice to FaceTime you yesterday. Quiz today during lunch. Good. When I say calculus, you say ready. Calculus.
Ready.
Calculus.
Ready.
Excellent. Good morning. And I have your quiz. Okay. So let's just rip the Band-Aid off the wound. The quiz results were disappointing. BC kids, you're not in this conversation. Just keep working. You should always just come in and work and get going. Okay. Everybody on this side of the room, the good-looking friends, results, here, there, just so you can hear them. 50, 70, 90, yay Sheila, 72, 50, 87, nice job Evel, 70, 53, 91, nice job Karina, hope everything comes out okay, 51, 59, 50, 55, 50, 62, 71, 66, 71, 62. Not so good. Okay. Now let me say the thing that's going to make this even worse. This is the easiest quiz that is going to exist in this course all year. Okay. Do I have everybody's attention? I think I do. I am not saying this to be mean. You all chose to be an AP Calculus, either A, B, or BC. Maybe someone lied to you and said it was going to be easy, and you're like, oh, you're going to love Mr. DeRozier. Eventually, yes. Eventually, yes. But what needs to happen between hearing that and success in 266 days is figuring out how to be successful in a college level course. Now, for most of you, this is not the first ever AP course, right? And I'm not yelling, I'm not screaming, I'm not like, this is crap, I'm wasting my time. The results were about what I expected they were going to be. But I also need this part to come through loud and clear. In order for the grades to get better, you all need to learn how to prepare for success in a college level course, which means doing the homework every single night. And I might make a lot of eye contact over here with Adrian, but Adrian, it is not just you, it's like 20 other people as well. Rebecca, just have a seat anywhere you'd like, it's fine. Have a seat anywhere you'd like. So that's part of it. The other part of it is figuring out to study for quizzes. Friday, when I said, hey, we have a quiz, there's this homework assignment, I'm going to pass it out, I'm not going to collect it on Monday, I'm going to send you the solutions. The very first part of that homework assignment was parent functions. Very first part was parent functions. First part of the quiz? Parent functions. Then there were like a whole bunch of questions on different ways to evaluate limits. On the quiz, a whole lot of questions about how to evaluate limits. This is not rocket science. This is not a surprise. This is the quiz you guys were prepared for. Yesterday, right before the quiz, and I thought, God, I'm getting easy in my old age. This is not what I've ever done before. I went over two problems that were really hard. One of them was working with piecewise functions. The other one was that difference quotient, the f of x plus h minus f of x all over h, because I knew those were on the quiz. That was a gift. It was gift wrapped. Some of you, I don't think, opened the gift. I love you all. We are going to get through this. It's going to take a change in the way that you're studying in order to be successful. Okay? All right. So, anybody interested in finding out how to improve upon their grade? Good. Okay. You don't even know what your grade is. So, in order to improve upon the grade, you need to, number one, make corrections to every single problem on this quiz. I'm available today during lunch and Thursday during lunch to help with those corrections. Thursday during lunch, next Monday during lunch, and next Tuesday during lunch are all going to be opportunities where you can come in and you can reassess. It'll be a very similar yet different quiz. And if you do better, then this grade goes away like it never ever happened before. Okay? I also need you to understand there are no more reassessments after this one. This is it. This is the one. Okay, second thing, and then I'm going to take attendance. I have 1, 2, 3, 4, 5, 6, 7 names that are highlighted on here. So the grade sheet is coming around right now. Everyone can see it. If your name is highlighted, you will be here today during lunch to continue working on the summer assignment. Because you're missing one or more parts, or you have an incomplete in one or more parts. If you're not here today during lunch, you will have after-school detention tomorrow. If you're not here on Thursday, you will have after-school detention on Friday. I hate playing this game, but it is part of how we're going to get moving in the right direction. Okay, I'm going to take attendance. Paul, do you mind passing these out? Okay, and I see 4, 8, 10, 14, 18, 21, 24, 28. I'm missing 2, 29. Somebody's missing a friend. I should have 30. I see 7 BC students. Who's missing a friend up here? Somebody's missing. 4, 8, 12, 16, 21, 4, 8, 30. Oh, I got everybody. I'm not missing anybody. My bad. Okay, everybody needs to have out the unit guide. You're going to find lesson 10. So sorry. All right. All right. So BC friends were all working.
It was +2.
Okay, good. All right. So AB friends, thank you. Yeah.
Oh,
I got it.
multiple.
Okie dokie. All right, so AB friends, I'm really excited. I've decided to go rogue. I'm going to go in an order that I've never gone before. Normally we spend 3 days on asymptotes and all the things. I decided to go in a different direction because I think this is a smarter way to go. And trust me, when my gut says that there's a smarter way, I'm going to trust my gut. It's helped get me to where I am today. So today we're going to focus on continuity, which is not a new word, right? This is something that we're all really familiar with. So when I say continuous functions, I need some examples of continuous parent functions. Feel free to use the survival guide if you need to. Raise your hand when you can think of an example of a continuous parent function. Use that survival guide if you need to. Jeanette's got one. Everybody should be able to generate like 5. Henry's got at least one. Go for that survival guide if you need to. Paul's got one. I'm looking for at least 5 continuous parent functions. Henry, get me started. Okay, y equals the square root of x, right? That's the one that looks like this, is a continuous parent function. Everybody okay with that? Yeah. Good. Karina, are we filming? Okay, good. Okay, that's one. I need some more. I need some more hands. Y equals the square root of x is a continuous parent function. If you don't know them off the top of your head, they're in that survival guide. Jeanette, give me another one.
Y equals x.
Y equals x. That line that passes through the origin is continuous. Paul, give me another one. Y equals x squared. The parabola is continuous. I need some more. Need some more. A whole lot more. Daisy.
Y equals x cubed.
Y equals x cubed, right? The curvy one that passed through the origin. Karina.
Y equals cos x.
Y equals cosine of x. Now we're getting sexy. Now we're getting a little bit exotic. Y equals cosine of x is a continuous parent function. There's a lot more. I can think of at least 5 more. Go through that survival guide. I heard y equals x. I heard y equals x squared. Y equals x cubed. Cosine of x. Henry, give me another one.
Y equals e kx.
Y equals e to the kx, or even just the basic like y equals e to the x, that exponential that increases from left to right. How about y equals natural log of x? That would work. How about y equals sine of x?
Yeah.
How about absolute value of x over x?
No.
Absolute value of x over x. If you just said yes, I think it's because you don't know what that graph looks like. What is that? Can you guys show me with your arms? Absolute value of x over x? Now let's get this straight. The orientation is this way. Here's the line y equals -1. Here's the line y equals +1. Can we all agree this is not continuous? Okay. How about y equals the absolute value of x? That's the v. We're good. How about 1 over x squared? 1 over x squared. 1 over x squared.
One like that and one like that.
Y equals 1 over x squared. That's the one there's a vertical asymptote in the middle and it increases. Okay, so that one's not continuous. How about 1 over x squared plus 1?
Yes.
1 over x squared plus 1.
Yes.
That's the one that does the hill shape. Is everybody okay? We know about continuous functions. I bet in 8th grade somebody told you there was a trick. There was something you were told. There was something about a continuous function.
It does not jump or it has cross.
There's that, but that wasn't 8th grade language. All right. Jose, can I get you to read back in middle school?
We all learn the definition of continuous function. A function that you can draw without lifting your pencil off the paper.
Okay, pause right there. Does everybody remember that? A continuous function, you can draw it without picking your pencil or your finger off the paper. That is a very middle school definition of continuous. It is not the high school calculus version. Let's keep going, Jose.
Sadly, if you write the last statement as your offense of why a function is continuous, you will receive no points on the free response portion of the AP exam. Sad face.
Thank you for saying sad face. Next time I'll get somebody with a theater background. Keep going.
The graders are looking for something much deeper and
Mathematically correct. Okay, is everybody okay? These 3 functions over here are continuous. 100% okay.
Yes.
Right, can we draw this without picking our pencil off the paper?
Yes.
Good. Adrian, you write that on your paper. I'm going to laugh at you. No, I won't. I'll yell at you instead. Okay. Visually, we're good with what makes a continuous function a continuous function?
Yes.
Good. All right, Paul, can you go from there? We can see from the graphs.
You can see from the graphs that all 3 of these functions are continuous. Sadly, writing this statement, I can see from the graph that the function is continuous will also receive 1 point on the free response portion of the exam. Sad face.
Oh, another spoken sad face. I need energy and oomph. Keep going, Paul.
You have to teach it in my function training in the way of properly communicating in functions indeed continuous evidence.
Okay, so here's where we are right now. I think we all understand what makes a continuous function, if you see it. But what you might be tempted to write is, well, I can see that it's continuous, or I can draw the graph without picking my pencil off the paper. We do not do that. Marilyn, that would be the absolute worst thing to do. That does not count. So let me teach you the ways. In order to show that a function is continuous at a point, there are 3 things you're going to have to show me. So my function's name, the function we're just going to say f of x, you have to first of all show me that f of c is defined. That's the first thing. That there's actually a point on the graph there. That's not going to be enough. The second thing is you need to show me that the limit as x approaches c of f of x exists. Well, if the limit as x approaches c of f of x exists, what does that mean? What does it take for a limit to exist? Go for it. The limit from the left and the limit from the right have to be equal to each other. Are we okay?
Yeah.
Okay, so let's just maybe put like a little note. This means that the limit as x approaches c from the left of f of x is equal to the limit as x approaches c from the right of f of x. Now the last thing is this extra step. You have to show me that the limit as x approaches c of f of x is actually equal to what f of c is. Number one, you're showing me that the function is defined. There's a point there. Number two, you're showing me that the limit exists. Number three, you're showing me that all those things are actually equal to each other. Okay, take a minute, get that copy down, and then we're going to do a little power teaching. Because power teaching is good.
What is that? Like f of x equals f of c.
The limit as x approaches c of f of x is equal to f of c. So the answer that you get from finding the limit, what happens as you get close, is equal to the value of the function at the same point. Okay? Everybody get it in the notes? All right, everybody up on your feet, please. And if you remember doing this last year with Mr. Link, you can thank me because he stole my moves. Woo! I got moves. I got moves. I'll do it once, publicly shaming myself, and then we'll move the camera around and shame you all. Okay, stay with me. In order for a function to be continuous, there can be no holes. Show me your hole. I can't believe I just said that out loud. There can be no jumps, a jump discontinuity. There can be no breaks, like a part of the graph over here, a part of the graph over here, and nothing in between. And there can be no, this is the fun one, vertical asymptotes. Isn't that what you do in a vertical asymptote? Right? That like dotted line thing that's happening vertically, no vertical asymptotes. Okay, back to your hole. The hole is considered a removable discontinuity. Cover up your hole. Don't think about it too much. Okay. All right, here we go. On the count of three. 1, 2, 3. In order for a function to be continuous, there can be no holes, no jumps, no breaks, and no vertical asymptotes. A hole is considered a removable discontinuity. Okay, just the men this time. The count of three. 1, 2, 3. In order for a function to be continuous, there can be no holes, no jumps, no breaks, no vertical asymptotes. The hole is considered a removable discontinuity. Everybody good? Okay, we got this under control. And you did this last year with Mr. Link. Don't sit down. Don't sit down. Don't sit down! Okay. So, now we got that. Now let's go over those 3 steps to show that a function is continuous at a point. So, I'll do it first, and I'm going to do this carefully because there's a little story that goes with this. In order for a function to be continuous at a point, we're not talking about continuous everywhere, but continuous at a point, the function must satisfy 3 conditions. Number 1, f of c is defined. Why am I making a fist? What's the significance? This is the point. Number 2, the limit as x approaches c exists. Why am I coming in this way and this way? Limit from the left, limit from the right are equal to each other. Now here's the thing. Could the limit exist and the function have a hole?
Yes.
Would the function be continuous?
No.
No. This is why I need the 3rd piece. To be continuous, that limit has to be equal to f of c. So not a hole, but close the hole. Everybody okay?
Yes.
If the function fails even one of these conditions, the function is said to be discontinuous at x equals c. Here we go, on the count of 3. 1, 2, 3. In order for a function to be continuous at a point, the function must satisfy 3 conditions. Number 1.
F of c is defined.
Number 2. One more time. Limit as x approaches c of f of x, or I think some of you are saying limit of f of x as x approaches c. Same thing. Same, but I want to see the hands. Limit as x approaches c from the left and the right, they're equal to each other. And then the 3rd thing, everybody, back to that. Number 3. Is equal to f of c. You have to show the equality of L. I have no idea what you were just doing back there. Okay, if the function fails even one of these conditions, the function is discontinuous at x equals c. Okay, one more time on the count of 3. 1, 2, 3.
In order for a function to be continuous at a point, the function must satisfy 3 conditions.
Number 1.
F of c is defined.
Number 2. Exists. Number 3. Is equal, not f of x, so f of c. Ears this big, I hear everything. Is equal to f of c. If a function fails even one of these conditions, the function is discontinuous at x equals c. We had a men only, now it's time for the ladies only. It's going to sound like angels singing from above. Okay. Okay, ladies. Men, you can have a seat. Ladies, here we go. Okay, on the count of 3. 1, 2, 3.
In order for a function to be continuous at a point, the function must satisfy 3 conditions.
Number 1.
F of c is defined.
Number 2.
The limit of x approaches c exists.
Number 3. The limit as x approaches c is equal to f of c. That's starting to hurt. I'm not sure if I'm doing a Miss Piggy right now or something else. It's one of those. All right. Hey, Diego, you might want to touch your shirt. It came untucked. All right. So now let's see how smart you all really are. All 3 of these functions, I'm at the top of page 26. Would we all agree these are discontinuous functions?
Yeah. Yes.
What's wrong with the first one?
There's a hole.
There's a hole. What's wrong with the second one? There's a jump discontinuity. What's wrong with number 3? Vertical asymptote. So they're all discontinuous. All I want you to do, take a minute with the folks that are around you. Of the 3 conditions, which one is not being met here, here, here? Go back to your notes if you need to.
For the first one.
Okay, but write it out of your notes. What's the actual condition?
Oh, no.
Yes. For the first one, FCC is not defined. Right?
You have a calculator that works, right? Do you have this?
But isn't there like...
Okay, let's worry about that. Let's worry about syllabus tomorrow. And I also need you to send me the email.
Yeah. What are these? The right
Okay.
Oh yeah, because it's a jump.
Mario.
So when it's a jump, it's always gonna jump.
What was it there?
Oh, for this one? Oh, but then again, like, I think this one is.
Alrighty, friends, here we go.
It's 2.
All right, of the 3 conditions, I want to get some hands on this. Which one fails? We see the graph, we know that there's a hole, but there's 3 conditions. The function has to be defined at the point, the limit has to exist, and that limit and how the function are defined have to be the same. Henry, which condition fails?
The first one is undefined, right? Because like.
So I heard, Henry, you just said that the function is not defined at 2. Do we agree? Look closely at the graph. Is the function defined at 2?
Yes.
Is there a point there?
Yes.
So actually, right, because of this guy right here, f of 2 is defined. Henry, are you okay with that?
Yeah.
Did you see the hole,
Yeah.
but you didn't see the point?
Oh, I did, but I didn't think anything else.
Okay, well that's a different problem. Okay, so there's a hole, I agree, but there is a point, so the function is defined. This moves me on to the next thought. Yes, ma'am, Sylvia?
It's
Does the limit of f of x doesn't equal
Now let's be really specific. I heard limit of f of x, but as x approaches,
c?
but let's be specific.
Oh, 2
At 2, what about it?
doesn't equal f of 2.
Doesn't equal f of 2. The limit as x approaches 2 of f of x is actually not equal to f of 2. Is everybody okay with this?
Also, it's 3.
Okay. Second one, fails to be continuous at x equals 2. I want to get some hands on this. Look at those 3 conditions. I see Jose. I only see Jose. I see Karina. Marilyn, what you got? Okay, I heard you say the limit from the left is not equal to the limit from the right. What are we thinking? Is she right? Right, the limit from the left is one number, the limit from the right is another number. The limit cannot exist, and if the limit cannot exist, you can't be continuous. But let's make this correct. Limit as x approaches 2 from the left, limit as x approaches 2 from the right. Thanks for that, Marilyn. Okay, last one. Which condition fails here? Jeanette, which one?
It has a vertical asymptote.
It has a vertical asymptote, but if we go back to those 3 conditions, which one failed? Which one failed? Michelle.
F of x is defined.
Wait, one more time?
The one of f of c is defined.
Okay, but it's not C in this case. What is it?
X.
F of 2. The vertical asymptote is at 2. So f of 2 is not defined. This is continuity. This is our calculus definition of continuity that involves limits. I hope everybody's okay. Chris, are you mostly okay? All right, good. So now it's time to push a little bit more. I love to push. So I'm taking away your graphs. No. Yes! There you go. You now have another 4 functions. And your job is to figure out why the function fails to be continuous and where the function fails to be continuous. I'm going to give you a couple minutes with this. If you want to use your calculator, if you need your calculator, it's okay to use the calculator. My preference would be, though, that you not go straight to the calculator. See what you can do. Okay?
So this one, number 1 is limit.
Yeah, I mean, I remember this one. This one goes to 1 and then negative 1.
Negative 1 and the other one is 1.
It's like that, right?
That's the jump.
But
So B number 2.
I checked that off the list. I moved on. The reason that I want you to have this,
but if it's
right?
0, then
Continuity, that's a parent function, and that's a parent function.
we're looking for x equals 0.
I'm good like this. Okay?
The bottom one says 0. The bottom one says 0. So it's but then it's not defined then.
Oh, the jump.
No, they're not even.
I mean, not the jump, though. You know this person? I mean, I know.
I think you're telling me, I think you need to be telling me something.
The plus one, oh, it's a little hill, right?
I was right.
So there are 2 reasons. Right, so on the first one,
That's 0.
You work both right. You know what you want.
unbounded behavior means that the graphs
You know that time
And you still wait, you still make it really tired.
and then when you sleep 4 hours, you're not tired.
It's kind of stay awake while
I feel like that is
What? No, I think I understand now.
This I know it's
That's the one that
be
that's the one that goes with the
a 2 or dot, and then I know it's a dot.
Alright, if I can pull everybody together just for a minute. Okay, so on number 1, if all goes well, this was meant to be the kind one, because this is straight up a parent function. And Paul was asking, like, how long is it going to take to memorize the parent functions? We're going to keep coming back to these parent functions every single day. Every single day until they really get planted in the brain. Now, I think most of you, if you know what this graph is it easy to say that this is discontinuous?
Yeah.
Where's the discontinuity? Discontinuous. Let's be specific though, at x equals 0. I heard somebody say f of 0 is not defined. Is that true or false?
False.
Look at the graph. Look at the graph. At 0, you have a hole and another hole. F of 0 is not defined. So all you need, that's one out, yeah. The other thing you could say is that the limit as x approaches 0 from the left is not equal to the limit as x approaches 0 from the right. If either of these things happens, not continuous at 0, get out and move on. Okay, keep going, see what you can do. Yep.
So we have the little places.
The graph is
So we have the
discontinuous at 0,
graph, right?
and what we're writing
we have
out.
a dot at 2.
How do you know it's discontinuous?
This one is equal to 2 as x equals 0.
So the instructions ask identify the location of the discontinuity.
It goes up to 1.
It goes up to 1. And then indicate which condition.
Because the highest
Get what I'm
value
saying?
is 1.
Yeah. Would it be does not exist? It does. We have. But then we have they're not equal.
But look, you're right.
Yeah.
Two is
But they do it.
meaning at x equals 0 is actually 1.
Yeah.
But what does that mean?
Oh, for this one, when it says like this, does it mean like there's
One is not
a
equal to 0
hole?
and it's less
Yep.
than 1.
Alrighty, friends. Okay, 1 over x squared plus 1, another parent function. Can you please draw that in the air for me? Draw that in the air for me. Okay. Some of you have like really big hills, and then we have the teeniest little. Okay. Okay, so I've seen a lot of folks drawing something like this. That's good. Karina's question was, but wait, if this is 1 over x squared plus 1, how do I draw 1 over x squared plus 1 if x isn't equal to 0? That just means remove x equals 0. You're going to put a little hole there. Now be careful, because that's not the entire piecewise function. Now this says if x is equal to 0, then there is a y value, and the y value is at 2. The question you have to ask yourself, though, is, does that fill in the hole, or is it up above, or is it down below? If you look at the graph, if x did equal 0, this would be the point, I think 0, 1.
Yes.
But we're getting the point 0, 2. With the graph in front, this is pretty obvious we're discontinuous?
Yes.
Where are we discontinuous?
X equals 0.
Discontinuous at x equals 0. And if somebody said why, you have 3 reasons. 3 things to check. First one, what's that first one?
F of C is defined.
F of C is defined, but be careful. Not F.
G.
G. Watch the function name. Is G defined at 0? Is G defined?
No.
Yes,
it is.
Look at the graph. Don't make the same mistake again, Henry. Look at that graph at x equals 0. Is the graph defined at 0?
Yeah.
Yes. Check. Second thing, limit. Does the limit exist? Limit from the left? Limit from the right?
Yes.
Absolutely. So what's the problem? There's a removable discontinuity, but it's that third statement. If I said limit as x approaches 0 of g of x, you guys would tell me 1. But if I said what's g of 0, you're going to tell me 2. Those aren't equal to each other. These guys are not equal to each other. Andy, that was the thing we were just talking about. The limit as x approaches 0 isn't equal to g of 0. What's that? You're good? All right, I want to do one last one together. Walking around, I don't think anybody actually made it to number 3. Is that fair? Okay. Number 3 is not a parent function. Take out your calculator, see what you can do.
You have like a solid.
Some of you are starting to doubt your calculator. Okay, quick show of hands. How many of you guys have that as your graph? And we are starting to doubt the calculator right now. Because this is probably not what you were expecting it to be. So this is the one I want to make sure I get all the brains on. Continuous or discontinuous?
Continuous.
Good save. Andy's like, that feels like a trap. That feels like a trap. The answer is you actually don't know. So let's run through this. Does it look like you can draw this without picking the pencil off the paper?
Yes.
Absolutely. It's a line. But look at the original function a little more carefully. Look at this with your pre-calculus information. Are there any problem points? Are there any domain restrictions? Are there any numbers that if you tried plugging them in, there'd be a problem? Evel?
Well, you plug in 1, the denominator is 0.
If you try plugging in 1, what happens is you get 0 in the denominator. Right, h of 1, and this is going to be a really subtle point here, h of 1 is 0 divided by 0. Which you guys are probably all going to tell me is the indeterminate form. The indeterminate form is for limits. Limits only. This guy here is not defined. So specifically, h of x is discontinuous at x equals 1. Because h of 1 is not defined. That's the issue that's happening here. You never, ever, ever would have known by looking at the graph. Is everybody okay with that? Yeah.
So if something comes up like that, you would tell us if you plug in like the number to see if there could be a 0.
What I would say is looking at the graph alone isn't good enough. There is something else you could look at on your calculator that could be helpful. Andy, what are you thinking? Oh, you had a question. Okay, I want to stick with my question. There's something else you could do in your calculator that might be helpful here. Marilyn, go to the table. Look at the table. Andy, look at the table. You're going to see it. It's going to pop right out at you. We're undefined?
Yes, sir.
Okay. So that's the thing though. You can't see it with your eye because what's happening is there's a teeny tiny, weeny hole. You can't see it. But it exists because we know we have a domain restriction. All the friends all right? We get this? Karina?
if you have like the exponent like longer, I mean not longer, bigger than the bottom, would that just be x?
There's other things happening there that we're going to talk about. All right, friends, I want to move on a little bit. So here's the thing, and this is going to be the last one that we're going to do, and then you guys will actually have some time to start on the corrections. We're on page 27. Tomorrow is going to be a practice day where we're just going to focus on limits and getting this right. So from today until the rest of eternity, when we talk about continuity, I'm going to ask you to prove it. And to prove continuity, there is a 3-step process. And the VC friends, I mean, depending on what you're doing, you might want to listen to this. I need to see all 3 steps. You're going to have to write out all 3 things. The first thing that you're going to show me, there were those 3 things. In order for a function to be continuous at a point, the first thing?
Show that f of x is defined.
The function has to be defined at the point. The second thing?
Show that limit of x.
The limit has to exist. The limit from the left and the limit from the right have to be equal to each other. And the third thing? That's not the third thing.
Show that.
Go back to the notes. Go back to the notes. If you're not sure, go back to the notes. Function is defined. Limit from the left and the right are equal to each other. And the third thing is that the answer you get in the first step, the answer you get in the second step, they better be equal to each other. So let's take a gander. And the notes up here are just a summary for you in the Say It Like a Boss section, brand new for the AV friends this year. You might want to highlight this or put a little star next to this, because our next quiz, oh my gosh, notation, so important. All right. So I want to show that this function is continuous. I want to prove that it is. It's this word prove. If you're not sure, it means like, show me. Show me that the function is continuous. This is like being back in geometry class. Yay, good times there.
Oh no.
I want to show that the function is continuous at x equals 1. It might not be a bad idea for you to just jot down, there's 3 things. Number 1, you're going to find f of 1. Number 2, we're going to find the limit as x approaches 1 of f of x. And number 3, you need to show me that the limit as x approaches 1 of f of x is equal to f of 1. I need all 3 of these. So with that said, see what you can do. We're going to walk around, make sure your shoes match your belt. Awkward and tacky when they don't match. Brown belt, black shoes, ugh. I don't even want to talk about those shoes.
Oh.
I'm just jealous. 3 pairs of I am looking for excellent notation. Be careful.
Yeah, but then I don't know. I mean, it's the second one, right? This one?
No, this one.
Yeah, that's where you plug in 1. It gives you e to 0 minus 3. And e 0 equals negative 2.
Pi is 1 no, pi is 1. In degrees, it's still pi. Charlie 180. So it's 0, so that's 1. So that's 1 times 2.
So number 2
You sure about it? Yes. No, yeah, okay, but I don't know what's right.
How do you say about you using friends?
Okay, back in. Pull everybody back together for a second. Good news here. 21 people are off to a good start. 4 people, not so good. 4 people wrote f of 1 equals 2 times cosine of pi times 1 as their opening move. What's wrong with this? What's wrong with this right away? It is screaming off the paper. Yes, ma'am.
Is it because they were like putting it together instead of like kind of like simplifying it more? So it's like pi times 1.
That's actually not the problem. Look at what they wrote here. What's going wrong?
X has to be less than 1.
F of 1 means the x is 1. This is not approaching, this is an is, right? Paul, what's f of 1 going to be? How am I going to find f of 1?
I thought you had to put it into the second.
Right, the second one, because this is the one where it's equal, so I'd say it's e to the 1 minus 1 minus 3. Okay, e to the 1 minus 1, well that's e to the 0. Minus 3, e to the 0, everyone's going to tell me is? 1. 1. Minus 3, everyone sounded like just Jose Rubio. Is negative 2. Great, you're on the board, you're doing this right. Now I've got to come over, and it's just like the conversation we had yesterday. Limit as x approaches 1 of f of x. Which piece do I use? Which piece? Because I'm approaching 1, I need to consider approach from the left and the right. And your notation better match limit as x approaches 1 from the left, limit x approaches 1 from the right. If you approach 1 from the left, that's this top function, 2 cosine of pi times x. The one on the bottom, e to the x minus 1 minus 3.
2.
I saw a lot of people that are doing this right. It's good. Chris, to find the limit as x approaches 1 from the left, the first thing I'm going to try, I'm just going to plug in. Can I plug in? So 2 times cosine of pi times 1. Pi times 1, you guys all know is pi. Cosine of pi. Now we get really quiet. Go back to that unit
Negative
circle.
1.
Okay. On the unit circle, the horizontal is the cosine, the vertical is the sine. Pi is over here. How long is that horizontal? Negative 1. So we get negative 2. Do it from the right. E to the 1 minus 1 minus 3. We've already been here before. Negative 2. Guess what? Everything's equal to each other. Everything's equal. So I'd say something like this. Since f of 1 is equal to the limit as x approaches 1 of f of x, I want to be careful here. Everybody okay with these? This is true? This is that third step. Hold on, Karina. What's the conclusion? What can I say? F of x is continuous. I just heard f of x is continuous. We have a problem. If this is what you write, we have a problem.
You haven't checked the third.
We actually did check the third thing. Where are you saying the graph is continuous? At x equals 1. All that you did is show that the function is continuous at x equals 1. That's all you did, Rebecca. Right? We tested f of 1. We did the limits as x approaches 1 from the left and the right. Everything matched up. The function is continuous at x equals 1. Diego, if you forget to write this, then just like me, your statement is too strong. You're saying it's continuous everywhere. Karina.
For step number 2,
Yep.
for 2 cos pi minus x, how come you plug in negative 1 if it's supposed to
I
be...
didn't plug in negative 1.
I mean 1.
Because we're getting close to 1 from the left, like 0.9, 0.999, 0.99999. You're getting as close to 1 as you can get, so we just plug in 1. Okay? Now, last thing. I need to talk to you guys about what's going to happen on the College Board exam. We just showed the function is continuous where? At 1. If they then said, hey, now go show that the function is continuous somewhere else, you gotta do it again. And they say somewhere else, you gotta do it again. You keep on going unless you know. Can anybody convince me that they know about 2 cosine pi x? Is there anything you know about this function? 2 cosine pi x. Anything anybody knows? Henry, what do you know?
Number less than 1.
For any number less than 1, think about that cosine graph, right? The cosine graph? Is that continuous?
Yes.
So this piece is continuous over here. How about e to the x? Is that continuous?
Yes.
That's another continuous function, right? But e to the x minus 1, that just means shift 1 to the right.
Yes.
It means shift down 3. Is that still continuous?
Yes. Yeah.
Right. Continuous function, and when I snap them together, continuous. So at this point, continuous everywhere. Pretty good? I realized I didn't tell you guys what the homework was. My apologies. Good news, there is homework. So if you could write this down, please. It's assignment number 9. It's on page 63. It's problems 3 through 10, 15, and 19 through 26. 3 through 10, 15, and 19 through 26. This is due Thursday. Hold on. Some of you just heard, I don't have any calculus homework tonight. Don't be dumb. Don't be the dummy. That's not what I said. I said this is due Thursday because some of you need to meet with me so that you can work on corrections. Some of you have lunch detention with me, and some of you are just going to get a good running start on this because it's due Thursday. Whichever group you're in, see you later. Evil, what do you need?